Every year, supply chain leaders pour millions of dollars into advanced tracking hardware and enterprise artificial intelligence platforms. Yet, despite this massive capital expenditure, their logistics networks remain blind to critical operational shifts. The root cause of this blindness is rarely a failure of the physical hardware itself. The sensors work exactly as designed. The actual failure stems from entrenched business practices and systemic flaws within the underlying data infrastructure. To understand why, we have to map the 7 specific types of supply chain visibility, audit the technology currently deployed, dissect the 5 data pitfalls crippling these systems, and outline the single structural solution required to fix them. Solving this paradox is the only way to convert a strictly reactive logistics network into a proactive, trusted ecosystem. The first major advantage of true visibility is the ability to rapidly react to operational exceptions like port strikes or weather delays before they cascade into unmanageable bottlenecks. When you have clear, immediate insight into inventory levels and transit status, management becomes a proactive discipline. You intercept problems before they fully materialize. That accurate data directly feeds superior resource planning. It allows for precise forecasting, optimized delivery schedules, and drastically reduced overhead costs. Furthermore, transparent cargo movement establishes systemic trust. It forces collaboration between previously disconnected stakeholders across the logistics lifecycle. Achieving true visibility is the absolute prerequisite for agility and resilience across the entire supply chain. The first major error executives make is treating visibility as a single monolithic feature. It is a composite of highly fragmented layers. As this architectural model shows, there are exactly 7 non-interchangeable types of supply chain visibility. At the foundation, you have transportation visibility, locating the physical cargo, and capacity visibility, which identifies choke points in the broader network. Above those sit shipment data analytics for measuring historical performance and rates visibility to manage transportation spend. The operational core consists of supply chain planning visibility for forecasting and operational visibility for proactively managing current movements. Finally, the highest layer is strategic supply chain visibility, leveraging all lower data points for long-term process innovation. When leadership buys new technology without explicitly defining which of these 7 distinct layers they are targeting, the implementation is guaranteed to fail. The technological arsenal required to achieve all 7 of these layers is readily available on the market today. At the base level, you have the generation tools, Internet of Things or IoT, tracking sensors attached to freight, alongside data integration APIs to pipe that telemetry into corporate systems. Then there is digital identity technology, which creates a secure cryptographic record to ensure trust between competing supply chain partners. At the highest tier is AI-driven decision intelligence, designed to automate complex logistics workflows and execute optimal routing without human intervention. As illustrated here, in theory, these tools stack together to form a flawless automated logistics machine. Raw data points seamlessly flow upward through interconnected processing blocks, culminating in a highly accurate analytics dashboard. But in real-world applications, this perfect theoretical stack shatters. The components fracture into isolated, disconnected boxes, permanently trapping the data points inside them. Authorizing a multi-million-dollar budget for advanced decision intelligence accomplishes nothing if the foundational data architecture feeding it is broken. This brings us to the first of 5 data readiness challenges preventing total visibility: the silo effect. The global supply chain is highly fragmented. Relying on simple application programming interfaces, or APIs, which allow different software applications to communicate, is severely insufficient to bridge decades-old legacy systems with independent, modern carrier portals. This leads directly to the second, more philosophical pitfall: the byproduct mindset. For decades, leaders have treated critical logistics data as mere exhaust fumes, a byproduct generated by transient enterprise software. To achieve visibility, there must be a structural shift. Executives must elevate data to a persistent, independent, corporate-wide asset. If your critical data does not live independently of the software that generates it, your company's operational visibility will reset to zero every single time you change vendors. The third pitfall is the operational fragmentation of shipping data across planning, financial, and active operational systems. Solving this massive linking challenge requires a universal cross-functional identifier. You need a shipper-generated load ID to act as a definitive anchor across all departments. Without that anchor, you hit the fourth pitfall, actionable intelligence chaos. Artificial intelligence models and advanced analytics engines cannot process highly siloed, chaotic data. When the input is fragmented, the system cannot generate decision-ready insights. The structural failure compounds into the final pitfall, slow motion information. Relying on batch processing and manual reporting is a fatal flaw in a global economy moving at algorithmic speeds. Operating at slow motion speeds with chaotic, fragmented data guarantees physical supply chain breakdowns. No amount of hardware or software purchasing can overcome that math. The visibility paradox cannot be solved by purchasing more tracking hardware or isolated AI tools. Fixing these five pitfalls requires a singular structural solution, implementing a data readiness framework. The first action step of this framework is to formally decouple your critical data from enterprise software, permanently establishing it as an independent corporate asset. The second step forces interoperability. A universal load ID cleanly synchronizes your finance, planning, and operations departments. Finally, the infrastructure transforms to support high-velocity data ingestion, ensuring AI applications have a constant, clean feed to analyze. Data readiness is the necessary bridge. It is the exact mechanism that transforms isolated, failing technology deployments into a unified, decision-ready network. In a fully data-ready supply chain, the operational reality completely shifts. You move away from the state of reactive troubleshooting and physical delays and establish end-to-end horizontal visibility across the entire product lifecycle. Total supply chain visibility is an exercise in data architecture, not a software acquisition strategy. Supply chain executives must audit and repair their foundational data infrastructure before deploying a single new AI or IoT project. Elevate and prepare the data first. Only then will the supply chain achieve the reliable, real-time awareness it requires to be truly resilient.
Hello, this is Raina McClure from SC Tech Insights. Thank you for listening. For more on this topic, click the article link below or go to www.sctechinsights.com for the latest insights on supply chain technology. Thank you and see you next time.